Have you ever wondered how a gasoline engine ignites the air-fuel mixture thousands of times every minute? Every time you start your vehicle, a series of electrical events takes place in just milliseconds. The ignition system transforms a simple 12-volt battery supply into more than 30,000 volts, enough to create a powerful spark inside each cylinder. Without the ignition system, your engine simply would not run. In today's video, we'll explain exactly how the modern ignition system works, the function of every major component, different ignition system designs, and common faults technicians encounter during diagnosis. Whether you're an automotive student, technician, or simply interested in how modern vehicles operate, this video will give you a solid understanding of ignition system fundamentals. Let's get started. What is the ignition system? The ignition system is responsible for producing a high-voltage spark at precisely the right moment to ignite the compressed air-fuel mixture inside each cylinder. This controlled combustion creates pressure that pushes the piston downward during the power stroke. For combustion to occur, three things are required. Air-fuel spark. If any one of these is missing, the engine will not start or run properly. Modern ignition systems are electronically controlled, allowing extremely accurate spark timing under all operating conditions. Always verify the complaint. Before replacing any ignition components, always verify the customer's complaint. Is the engine experiencing a no-start condition, a rough idle, an intermittent misfire, or a lack of power? Every symptom provides clues that help narrow down the root cause. Never assume a failed ignition coil or spark plug without first confirming the actual problem. Main components. Let's look at the major components. Battery. Everything begins with the battery. The battery provides approximately 12.6 volts with the engine off and around 14 volts while charging. Although 12 volts cannot jump a spark plug gap, it provides the energy needed by the ignition coil. Check battery voltage first. One of the most overlooked causes of ignition problems is low battery voltage. A weak battery can reduce ignition coil performance, prevent the PCM from operating correctly, and even create false diagnostic trouble codes. Before performing any ignition diagnosis, measure battery voltage. A healthy battery should read approximately 12.6 volts with the engine off and between 13.5 and 14.8 volts with the engine running. Ignition switch. When the driver turns the key or presses the start button, battery voltage is supplied to the ignition system. The engine control module also wakes up and begins monitoring engine sensors. Engine control module. The PCM acts as the brain of the ignition system. It receives information from sensors including crankshaft position sensor, camshaft position sensor, throttle position sensor, engine coolant temperature sensor, mass airflow sensor, manifold absolute pressure sensor. Using this information, the PCM calculates the ideal ignition timing. Use a scan tool. Before replacing parts. Modern vehicles provide a wealth of diagnostic information through the OBD2 system. Always connect a scan tool before replacing any parts. Look for stored, pending, and permanent trouble codes. Monitor live data such as engine RPM, ignition timing, crankshaft position sensor activity, misfire counters, and fuel trims. The scan tool often points you in the right direction before you even open the hood. Crankshaft position sensor. This is one of the most important sensors. Without it, the PCM doesn't know engine speed, crankshaft position, which cylinder is approaching top dead center. No crankshaft signal usually means no spark, no injector pulse, no engine start. A no-spark condition doesn't always mean a bad ignition coil. Many technicians immediately suspect the ignition coil when there is no spark. However, a failed crankshaft position sensor is actually one of the most common causes of a no-spark condition. Without an engine speed signal, the PCM will not command the ignition coils or the fuel injectors. Always verify that the PCM is receiving a crankshaft signal before condemning the ignition coil. Camshaft position sensor. This sensor identifies which cylinder is on the compression stroke. It allows sequential fuel injection and coil-on-plug ignition systems to fire the correct cylinder. Ignition coil operation. Now let's understand the ignition coil. The ignition coil is essentially a transformer. It converts 12 volts into anywhere between 20,000 and 50,000 volts. It contains two windings: primary winding, secondary winding. When current flows through the primary winding, a magnetic field develops. The PCM then suddenly interrupts the current. As the magnetic field collapses, it induces extremely high voltage in the secondary winding. This voltage travels toward the spark plug. This entire process happens in just a few milliseconds. The coil before replacing it. Don't replace an ignition coil simply because a misfire is present. Use a scan tool to identify the affected cylinder. If the vehicle has a coil-on-plug system, swap the suspected coil with one from another cylinder and clear the codes. If the misfire moves to the new cylinder, you've confirmed a faulty coil. If the misfire stays on the same cylinder, continue checking the spark plug, injector, compression, or wiring. Spark plugs. The spark plug is the final component in the ignition system. Its job is simple: create a spark across a precisely measured gap. That spark ignites the compressed air-fuel mixture. Spark plugs operate in one of the harshest environments inside the engine. Temperatures exceed 800 degrees Celsius. Pressure exceeds 1,000 psi. Over time, spark plugs wear. The gap increases. Misfires become more common. Fuel economy decreases. That's why manufacturers recommend replacing spark plugs at specified intervals. Inspect spark plugs carefully. A spark plug can reveal a great deal about engine condition. A light tan or gray color generally indicates normal combustion. Dry black deposits suggest a rich fuel mixture or weak ignition. Wet fuel on the plug may indicate no spark. Oily deposits can point to worn piston rings or valve seals. A white, blistered insulator often indicates overheating or a lean air-fuel mixture. Always inspect the old spark plugs before installing new ones. Ignition timing. Spark timing is critical. If spark occurs too early, the engine may knock. Power decreases. Engine damage can occur. If spark occurs too late, fuel economy suffers. Power decreases, emissions increase. The PCM constantly adjusts ignition timing based on engine load, throttle position RPM, engine temperature, knock sensor input, fuel quality. This continuous adjustment provides maximum performance and efficiency. Never ignore freeze frame data. Whenever a diagnostic trouble code is stored, freeze frame data records the engine operating conditions at the exact moment the fault occurred. Engine speed, load, coolant temperature, throttle position, and fuel trims can help reproduce intermittent faults. Many technicians skip this step, but freeze frame data often provides the key to solving difficult diagnostic cases. Check the wiring before replacing components. A surprising number of ignition problems are caused by damaged wiring, loose connectors, corrosion, or poor grounds, rather than failed components. Before replacing an ignition coil or PCM, inspect the wiring harness, connector terminals, and ground circuits. A 5-minute visual inspection can save hours of unnecessary repairs. Types of ignition systems. Modern vehicles use several ignition system designs. Distributor ignition. Older vehicles used distributor rotor cap, single ignition coil, mechanical timing advance. This design required regular maintenance. Distributorless ignition system. Instead of one coil, several coils are used. Many employ a waste spark configuration. 2 spark plugs fire simultaneously. Only one spark ignites combustion. The other occurs during the exhaust stroke. Coil-on-plug. Today's vehicles primarily use coil-on-plug systems. Each spark plug has its own ignition coil. Advantages include more accurate timing, higher spark energy, fewer moving parts, improved fuel economy, lower emissions, easier diagnostics. Don't forget mechanical problems. Not every misfire is caused by the ignition system. Low compression, burnt valves, vacuum leaks, incorrect valve timing, or fuel injector problems can produce symptoms that resemble ignition failures. Before replacing ignition components, verify spark, fuel delivery, and engine compression. Remember the golden rule of engine diagnosis: air, fuel, spark, and compression. Common ignition system failures. Some of the most common failures include worn spark plugs, failed ignition coils, damaged spark plug boots, faulty crankshaft position sensor, poor electrical connections, low battery voltage, PCM driver failures. Symptoms include hard starting, engine misfire, loss of power, poor fuel economy, rough idle, check engine light, use mode $6 data. Many advanced scan tools can access mode $6 data, which displays individual cylinder misfire counts before a check engine light appears. Monitoring mode $6 can help identify intermittent ignition problems early, allowing you to diagnose issues before they become more serious. Professional technicians don't guess, they test. Successful diagnosis follows a logical process. Verify the complaint, retrieve fault codes, analyze live data, inspect the system, perform electrical and mechanical tests, and only then replace the failed component. Following this method saves time, reduces unnecessary repairs, and builds confidence in every diagnosis. Conclusion. The ignition system may appear simple, but it's one of the most important systems in any gasoline engine. Every spark must occur at exactly the right moment, thousands of times every minute, to produce smooth, efficient engine operation. Understanding how the ignition system works is an essential skill for every automotive technician and enthusiast. If you found this video helpful, give it a thumbs up, subscribe to CarFacts Garage, and turn on notifications so you don't miss our upcoming videos on fuel systems, engine management, CAN bus, LIN bus, hybrid technology, EV systems, and advanced automotive diagnostics. Thanks for watching, and we'll see you in the next video.